Now let's do a worked example. The question is, calculate how much heat it will take to transform 100 grams of H2O from minus 25 C to 140 degrees C. To solve this, we'll need to break the problem into 5 parts. Firstly, we'll need to calculate how to raise the temperature of the ice from minus 25 degrees C to 0 degrees C. To do this, we use the relation that heat flow equals the specific heat of ice times the mass times delta T. Note that the specific heat of ice, not water, must be used here. Also note that ice can be at different temperatures. So putting in the numbers, the first part of the heat required equals 5,225 joules. We now have ice at 0 degrees C. So the second part of the problem involves calculating the heat required to melt the ice. To do this, we need to use the latent heat of fusion. So we have our mass times the latent heat of fusion, which calculates out at 33,300 joules. Now we have water at 0 degrees C. In the third part of the problem, we need to calculate the heat required to heat the water up to 100 degrees C. Using the specific heat of water this time, we can write that the heat flow equals Cm delta T, where delta T equals 100 degrees C. If we put in the numbers, we see that the third part of the heat flow, we get 41,860 joules. Now we have water at 100 degrees C, we need to calculate the heat required to transform it into steam. Here we need to use the latent heat of vaporization, which you might recall is a really large number. We multiply this by the mass, we end up with 225,600 joules. Finally, we need to raise the temperature of the steam from 100 degrees C to 140 degrees C. This is the last part of the problem. To do that, we need to use the specific heat of steam times the mass times delta T, which in this case is 40 degrees. We calculate that out, 7,960 joules. Let's write out the entire equation again. So our total heat equals the heat required to warm up the ice, plus the heat required then to melt the ice, plus the heat required to heat up the water, plus the heat required to vaporize the water, plus the heat required to heat up the steam. If we put in all these numbers from the previous section, we see we end up with approximately 314 kilojoules. It's interesting to look at the various percentages associated with the heat in this calculation. What's clear is that most of the heat is required to vaporize the water, 72% in fact. This is because this process requires a lot of energy. Finally, it can be helpful to plot these problems as temperature versus time, where we're assuming constant heat flow. This is a good way to visualize what's happening. In the first part with the ice, we're getting a change in temperature. In the second part, where we're getting a solid to liquid transformation in Q2, we are not causing a change in temperature. In the third part, we are causing the change in temperature where we're heating the liquid. The fourth part, again, no change in temperature. This is where we're changing the liquid to a vapor. And finally, in the fifth part, we've got the vapor heating up, and we have got a change in temperature.